Ever wondered if there's another you out there in a different universe, living a completely different life? This might sound like a plot straight out of a science fiction novel, but it's actually a concept deeply rooted in theoretical physics. Welcome to the enigma of parallel universes. Now let's try to understand. Picture the universe, that vast expanse of space and time filled with galaxies, stars, planets, and everything we know. Now, imagine that it's not the only universe. Rather, it's just one in an infinite number of universes existing side by side, like bubbles in a cosmic bubble bath. This is the concept of the multiverse. But it doesn't stop there. Each of these universes could have its own laws of physics, its own history, its own version of reality, and yes, that includes a universe where another version of you exists. This isn't just wild speculation, it's a serious idea proposed by some of the world's leading physicists. Now consider this. Every decision you make, every step you take, every word you say could create a new parallel universe. One where you chose differently, walked a different path, or said something else. It's a concept known as the many worlds interpretation, a theory that every possible outcome of every event defines a new universe. Is your head spinning yet? It's a lot to take in. But it's a testament to the sheer wonder and complexity of the cosmos. It's a reminder that the universe, or rather the multiverse, is far stranger and more fascinating than we could ever comprehend. So next time you're gazing up at the night sky, think about this. There could be an infinite number of universes out there, each with its own version of you. You might be a world leader in one, a best-selling author in another, or even a superhero in a third. Imagine in one universe you might be a scientist, in another a rock star. Makes you wonder, doesn't it? Now let's delve into a fascinating experiment that stirs up the conversation on parallel universes, the Double Slit Experiment. Picture this. You have a wall with two slits, and behind it, a photographic plate. You shoot tiny particles like electrons or photons at the wall. Logic would dictate that these particles would pass through one slit or the other and hit the plate behind, creating two bands corresponding to the two slits. But the reality of quantum mechanics gives us something more intriguing. Instead of two bands, you get an interference pattern, as if the particles were behaving like waves. This is strange because it seems as though each particle, even when fired individually, is passing through both slits simultaneously, interfering with itself and creating a wave-like pattern on the plate. This is known as wave-particle duality, a cornerstone of quantum mechanics. But it gets even weirder. If you place detectors at the slits to observe which slit the particle actually goes through, the interference pattern disappears, and you get the expected two bands. It's as if the particles know they're being watched and decide to behave differently. This phenomenon is known as the observer effect. Now you might be wondering, what does this have to do with parallel universes? Some interpretations suggest that each particle splits into multiple versions, each passing through one slit in a different universe. When these versions converge on the other side, they interfere with each other, creating the wave pattern. However, when we observe the particles, we are locking them into our universe, causing the interference pattern to vanish. This interpretation is far from definitive, and it's one of many attempts to make sense of the bewildering results of the Double Slit Experiment. But it certainly fuels the imagination, doesn't it? It's a tantalizing hint at the possibility that there may be more to our reality than what meets the eye. The results of this experiment continue to baffle scientists, posing more questions than answers. Quantum physics, the science of the very small, has something to say about these parallel universes. It's a realm where particles can be in two places at once, where they can spin clockwise and anti-clockwise simultaneously, and where they can even be entangled over vast distances. It's a world of startling possibilities, and it just might hold the key to understanding parallel universes. Let's dive into the weird and wonderful world of quantum superposition. This is a fundamental principle of quantum physics, and it refers to the ability of particles to exist in all their theoretically possible states at once. It's like having a coin that's both heads and tails at the same time until you look at it. Only when a measurement is made does the particle choose one state. Now, imagine this on a universal scale. Every time a quantum event happens, the universe chooses one outcome. But what about all the other potential outcomes? According to one interpretation, they play out in parallel universes. Now, let's move on to entanglement, another quantum quirk. It's a phenomenon where two particles become linked and instantly affect each other, no matter how far apart they are. If you change the state of one particle, the other changes too. This spooky action at a distance, as Einstein called it, could imply a deep connection between our universe and potential parallel ones. Some even suggest that quantum entanglement could be the bridge that links these universes together. In essence, quantum physics paints a picture of a cosmos far stranger and more complex than we could have ever imagined. It's a cosmos where parallel universes aren't just a possibility, they're a likelihood. And these aren't just passive, independent realms. Through phenomena like superposition and entanglement, they could be constantly interacting with our own universe. So, quantum physics suggests that not only could parallel universes exist, but they could also interact with ours. However, not everyone in the scientific community accepts the idea of parallel universes. Indeed, the concept has its fair share of critics and skeptics. Their concerns range from the lack of empirical evidence to the challenge of testing these theories, and these criticisms are worth our attention. One of the most significant criticisms is the absence of empirical evidence. Science, after all, is rooted in observation and experimentation. But the parallel universe theory, as fascinating as it might be, currently lacks direct observable evidence. We can't simply pack our bags and hop on a spaceship to visit these alleged alternate realities, at least not yet. This makes it difficult for many scientists to wholeheartedly embrace the idea. Another criticism lies in the realm of testability. For a theory to be scientifically valid, it must be testable and, crucially, falsifiable. This means we should be able to devise an experiment whose results could potentially prove the theory wrong. But when it comes to parallel universes, designing such an experiment poses a significant challenge. If these universes exist outside of our own and are governed by different laws of physics, how can we possibly test for their existence? Other critics argue that the parallel universe theory, while mathematically elegant, is scientifically extravagant. They suggest it's more of a philosophical speculation than a scientific hypothesis, as it proposes an infinite number of universes to explain phenomena in our own. This, they argue, goes against the principle of Occam's razor, which favors the simplest explanation. While these criticisms are robust, it's important to remember that they don't necessarily invalidate the concept of parallel universes. They simply highlight the challenges we face in exploring this intriguing idea. Many groundbreaking scientific theories, after all, faced intense scrutiny before gaining acceptance. The existence of parallel universes remains a contentious issue, with the scientific community divided. As always in science, the debate continues, pushing the boundaries of our understanding and keeping us on the exciting frontier of discovery. The implications of parallel universes are mind-boggling and far-reaching. The mere thought of them opens up a Pandora's box of philosophical considerations, each more intriguing than the last. Let's start with the concept of free will and destiny. If parallel universes are real, does this mean that every choice we make spawns a new universe? If that's the case, are our lives predestined, or are we truly free to make our own choices? In a world where every possibility is played out in some universe or another, the boundaries between fate and free will become blurred and the idea of destiny takes on a whole new dimension. Next, let's ponder over the nature of reality. If there are infinite universes, then what is real? Is our reality just one of the many possibilities? And if so, is it any more or less real than any other? It's like looking at a sea of mirrors, each reflecting a slightly different image. Each reflection is as real as the next, yet none of them are the original. Finally, we come to the question of identity. In a multiverse, there could be countless versions of you, each living a different life, making different choices. Are they all you, or are they separate individuals? And if they are you, what does that say about your identity? Are you just one piece of a larger, multidimensional self? These are not easy questions to answer, and they stretch the limits of our understanding. They force us to reevaluate our perceptions of reality, self, and existence. But that's the beauty of parallel universes. They challenge us to think beyond our ordinary experiences, to ponder over the mysteries of the cosmos, and to question our place in the grand scheme of things. Whether they exist or not, parallel universes certainly provide food for thought. They challenge our understanding of the universe and our place in it.